Hello, welcome to class. In today's episode of the class, we'll be looking at binomial expansion. Okay, on binomial expansion, our main focus is how to apply Pascal Triangle to find the expansion of a plus b raised to the power of n, and how we can also use the factorial theorem in Pascal's triangle. So this is our main focus for this class on binomial expansion. So before we proceed, I would just like us to use our basic idea of expansion to solve the following questions given to us. We have 25 x raised to the power of half. Okay, from this we have the law of indices. So the law of indices says a raised to the power of half is equals to root what? A. Or if you have a raised to the power of x over b, we have it as what? B with a multiply raised to x. Okay, so we'll be using these laws to solve our equation. So looking at this question given to us 25x raised to the power of half here, we are going to apply our indices to raise to our half 25. X will be what? Root of 25x. Okay, so square root of 25 is 5, and the square root of x is root x. So we have it as 5 root x. So moving to the next question. Please, this is not Pascal's triangle. We are coming to that. I just want us to solve this before we proceed using the Pascal's triangle. So we have 64x raised to the power of -2/3. Okay, if you have for our law, it says if e raised to the power of -1/2, it's going to be the inverse of a raised to the power of half. Okay, so this is what we are applying here. I will have 1/64x raised to 2/3. When you have a negative index, it means the inverse of your indices, whatever you're giving. So we have this here. I'm going to have 1 divided by, this gives us a cube root of 64x raised to 2. Okay, so 1 over cube root of 64 is 4, and cube root of x is going to be cube root of x. Okay, then remember we have our square here. This gives 1 over square of 4 is 16, and this gives me s cube squared. Okay, so this is what we have when you have this raised to your negative power. Then we have for the third one, our c says 9 divided by 100x raised to the power of -half. This gives our inverse function of 1/9/100x raised to half. So this gives us, I'll just switch it, the 100 goes up, then we are left with what? 9x raised to what? Half. So what do we have? We have the square root of 100 divided by 9x. Square root of 100 is 10, and square root of 9 is 3. So we have 3 root x. Then we have the last question that is 8/27 x raised to 4/3. So on that expression, it's just going to be what? Our cube root of 8/27x. Okay, so everything will be raised to 4. So I have it raised to 4 here. So the cube root of 8 is 2, and the cube root of 27 is 3. And the cube root of x becomes cube root of x. Okay, then we have it raised to 4. So this gives 2 raised to the power of 4, 16, then 3 raised to the power of 4 is 81. Then we have cube root of x raised to 4. So this is our basic idea of using indices for our expansion. Now we are moving on to the main focus of today's class, which is our binomial expansion. And on this binomial expansion, we are using the Pascal triangle. So I'll just give you a vivid idea of how the Pascal triangle works and how it looks like. So for you to be able to construct this on your own without having to memorize it. So the Pascal triangle is like a triangular method. So the first point we start with our number 1. Okay, so when your function is raised to the power of 0, for example, I have a raised to the power of 0. We know that for our law of indices, we say if a raised to the power of 0 is equals to 1. So we start with 1. Then when we have a function raised to the power of 1, I will have it as 1 and 1. I'm constructing the Pascal triangle. And so for any function raised to 1, it's 1. Okay, so we have it as 1 and 1. Then we move to when it is raised to 2, when you have a function raised to the power of 2. For example, you can have a plus b raised to 2, you can have any number raised to 2. So we start with 1 here. Then I add 1 plus 1. This numbers here added together, 1 plus 1. We give us 2. So this becomes 2. Then we have the 1 here is going to be brought down. Okay, so for every end of your Pascal triangle, you have a 1 at the beginning, you have a 1. So take note of that. So when it is raised to 3, what do we have here? I have 1, the first one is coming down. Then I have 1 plus 2 here. This one is added to 2, which gives us 3. Then we add the 2 to this 1 here. This also gives me 3. And I say the last one is always brought down. Okay, so that's when you have a function raised to the power of 3. Then when I have a function raised to 4, I will also have my 1 coming down. Okay, I have this added to this is 4. Also, you have this added to this gives 6. Then you have this added to this gives 4, and note your last one comes out. You can see it's already looking like a pyramid, your Pascal triangle. Then if you have a function raised to 5, we have it as 1. Also, you add 1 to 4 gives 5, 4 to 6 gives 10, 6 to 4 gives 10, and 4 to 1 gives 5. So this is the way to go with your Pascal triangle. So 1 to 4 here is giving me 5, 4 to 6 is giving me 10, 6 to 4 is giving me 10, then 4 to 1 is giving me 5, then you put your 1. Okay, then we have when it is raised to the power of 6. So the first is going to be our 1, then 1 to 5 is 6, 5 plus 10. So you're adding like this 5 plus 10, same pattern will come, then 10 plus 10, 10 plus 5, 5 plus 1. Okay, so 5 plus 10 gives 15, then 10 plus 10 gives 20, 10 plus 5, 15, 5 plus 1 gives 6, then we have 1. So you can continue this for as many powers as you can. It is an easier form of expansion. So you don't have to stretch your brain, you don't have to write expansion in 6 different places or 4 different places. So with the idea of a Pascal triangle, you should be able to solve complex equations that you need to expand. So you're going to see how this Pascal triangle works with our expansion. So we'll take examples on different forms of expressions that we are going to expand. So let's take a look at this few expressions before we move on to basic examples. So we have a plus b raised to the power of 0. Like I said, for any power we raise to 0, they give us what? We have 1. Okay? So any power raised to 0 must be equals to 1. So that's what we have on this a plus b. Then we have a plus b raised to 1. The first Pascal triangle on 1 is 1 and 1. So we have it as 1 and 1. That means the first power of a will be raised to the power of 1. Okay, in expansion, so we have a to 1. Then we have our ab, okay, which is also ab raised to 1. Then we have our b raised to 1. So you just see that the a has 1 and 1. So you just include your 1 and 1. So that is all. There's nothing that is going to be there. So it's just going to be a plus ab plus b. So this is what you have for your expansion. Then when we move on to a plus b squared, your first a, remember for our a value, our 2, when it is raised to 2, we have it as what? 1, 2. So we have it as 1, 2, and 1. So that means for my a, I will have a squared. Okay, so this is a raised to 2. Then you put the a and the b, which is having what? 2. So I'll have 2ab. Then the last guy is 1 there, so that will be 1b squared. So this is the expression for your Pascal triangle. Then the third guy is giving us a plus b cubed. So your first expression will be a cubed. And for 3, we have it as what? 1, 3, 3, 1. Okay, using your Pascal triangle. So the first is 1a3 plus 3. This is 1a cubed plus 3a squared b. Okay, take note your a is decreasing as you keep moving. Then plus 3a, 2 becomes 1. Then your b becomes what? Squared. Then the last will be your b cubed. Okay, so please take note of the peculiarity between the first and the last. The first is just this 1 raised to this power. Then the last expansion will be this raised to this. So it's just a simple idea logic for you to use. Then looking at what we have for binomial expansion of 4 as 1, 4, 6, 4, 1. Okay, so that's what you have. So that means the first will be 1 a raised to the power of 4 plus the other number is 4. Okay, so that will be 4a3 raised to 3. You keep decreasing. Then your b becomes just 1 along this point. Then followed by we have 6a squared b squared. Okay, then we have plus, next number is 4, a becomes 1 and b becomes 3. Then followed by the last, which is 1b 4. Okay, so this is our expansion using the Pascal triangle. So it is easy. So I would like us to go through examples using the Pascal triangle to solve our expansion. So this is what we have, find the expansion of x plus 2y cubed. So bringing down my x plus 2y cubed, x plus 2y raised to the power of 3. Okay, this is power of 3, and the power of 3 we have it as 1, 3, 3, 1. Take note of that. Just bring this down. Also, 1, 3, 3, 1 is what we are using. So, like I said earlier, the first you just raise it to what? S cube. Okay, which is 1s cube. Always your first is 1 and the last is a 1. So take note of that. It doesn't change. If possible, you write the first value and the last value to make your work easier. Then followed by this will give me x squared. Remember there's a 3 here. I'm putting the 3 outside. Okay, so we have 3s squared, 2y. Okay, because that first value becomes just 2y. Okay, then we'll proceed with what? Our 3. X becomes just x. Then we have 2y squared. Okay, then lastly, we'll just have our 2y raised to the power of 3. Okay, this is how it goes. Then that means 1s cube is just going to give me x cube plus 3x squared times 2y will just give me 6x squared y. Then we have 3 into x. 2y squared is 4y squared. 2y squared, that is 2y multiplied by 2y gives me 4y squared. So then we have 3 times what? X times 4y squared. Then 2y cubed gives me 8y cubed because 2 cubed is 8. That's 2 in 3 places. Then we have x cubed plus 6x squared y plus 12xy squared plus 8y cubed. So as your x is decreasing, okay, your y increases. So this is what the binomial expansion is. I will just go for the other example of 2x minus 5 raised to 4. Okay, on this, you just write our 4 is 1, 4, 6, 6, 4, 1. Okay, that is expansion before. We have it as 1 to 4 to 6. Okay, to 6, just 1 6, not double 6. To 6 and to 4 and to 1. 4 and 1. So this is what I have here. So in expanding this now, I will proceed with the first guy is just, I told you, it's always 1. But it's going to be 2x raised to what? 4. Okay, so followed by minus, we have 4 is the power there. 4 is the next number to put, so I'm using 4 into 2x. Remember your 2x becomes raised to the power of 3, and your 5 is just going to be 5. Then we have followed by minus 6 is the third number for your expansion, raised to what? 2x squared. Then we have 5 squared. Okay, then we have minus 4 into what? 2x becomes just 1. Then we have 5 cubed. Then we have 1 into what? 5 minus 5 raised to the power of what? 4. So you can expand this and you get the answer on that. So we have 2x raised to the power of 4. We give me 2 raised to the power of 4 is 16. X raised to the power of 4. On this, I have 2x cubed is 8x cubed. So I have 4 multiplied by 5 multiplied by 8. Okay, on this guy, 4 multiplied by 2s cubed is 8s cubed, then multiplied by 5. So this gives me 20 by 5. That's giving me 160x cubed. Then for this, I have minus 5 squared here. Okay, it's going to give us 6 into, remember the minus was for the 5. I'll just move it to the 5. So you have, it is going to be for this 5 squared. Okay, so this minus 5 squared gives us a positive 25. Then 2x raised to the power of 2 gives 4x raised to the power of 2 times 25. So you multiply this out. 6 by 4 by 25. I think that gives us 600. That's 600 x squared. And then we have we have 4 into 5 cubed here. This is 4 multiplied by 2x multiplied by 5 cubed is 125. Okay, so that means I have 4 times 2x, that's 8 times 125, will give us 1,000. So we have 1,000 x there. So we have 1,000 x, and the last guy will be minus 5 into 4. That gives 625. So we have plus 625. Okay, so this is how to use your Pascal triangle. It is quite easier than the long method for expansion. So try as many examples as you can. It's very easy. Follow the steps, take note of the last and the first beginning, and every other thing is easy. Just fix it in. As your value for x decreases, your value for the other guide increases. It can be y, can be any random number. So follow the Pascal triangle and use to solve.